See how we do on time. Initial position of a remote control car, number 6. Given an IJ meters, starts from rest and has a constant acceleration. Again, given an I and J components. What's the final position after 10 seconds? Say we want that in IJ notation. So this one is always good to determine what concept we're trying to test with these problems. This is two-dimensional motion, and the idea here is we have constant acceleration. Okay, we can split it up and work it as two one-dimensional constant acceleration problems. So we'll look at the x direction and the y direction, figure out the final position, and then combine it. So position is just a vector. So we'll write out x2 equals x1 plus vx1t plus 1/2 axt squared. Alright, so the x direction, there's my initial x, so that's going to be minus 15, plus, starts from rest, so this term is going to be 0. Okay, and there's my initial I, 1/2 times 1, and I'm going for t seconds, so 10 squared. So that's my x2 or x final. Alright. Oh, let's see. We'll do everything in a calculator just to sort of simulate the test here. So let's clear things out. Minus 15 plus 0.5 times 10 squared. Looks like about 35. And units on that would be meters. Okay, same equation for y, so I won't bother writing out the y equation, but I'll make sure we know what we're doing here. So in the y direction, we're going to have y2 is equal to, let's switch colors here, it's a little easier to see, minus 6 is my initial position, starts from rest, 1/2 minus 2. It's my acceleration and same time. Okay, so let's see what that does. Minus 6 plus 0.5 times minus 2 times 10 squared. So I'm trying to double check carefully so I don't make silly mistakes and I have to come back later. 106 negative minus 106 meters. So once my final position, so there's my final x, there's my final y, and so I would write that as 35I minus 106J meters. Still have to have units. That gives us the final position. 35 in x, 106 in a negative y.